Alright, hopefully you spent some time sketching out some solution using inheritance, and let's now try to compare your solution with mine. Okay, let me first of all emphasize that whatever I'm going to say now is going to be some less than ideal solution, and then we'll identify the disadvantages, and then we'll try to improve it by using the abstract keyword. So that'll be the flow. Hopefully this will be something similar to what you have got. Let's now go over the critical parts. Okay, so we got three classes. We got polygon as the common parent class for rectangle and also triangle. Right? You should now immediately identify these are the descendants, right? Like a proper descendants for polygon, right? And also polygon should be the ancestor for rectangle or triangle. So all the rules about substitution, also typecasting should still apply from what we have learned before. Let's take a look at the methods. In the polygon, we're going to declare everything that's going to be common and will be inherited to rectangle and triangle. For simplicity, I would simply just make them no modifier over here, meaning that it's going to be the package level visible, meaning that all the subclasses will be in the same package. If you want, you can also put protected before every one of them if you wish. Right? I'm going to leave that to you. Let's say let's talk about area a little bit later. So that's the more important method which I want to get into. Let's now talk about other methods first. Okay. So the first one is about how we represent each triangle and also rectangle. So we say the polygon is going to have an array of size. Okay. So here actually I happen to choose double. That's okay. Doesn't matter, integer or double. Let's say we got an array of double to represent the size. So you can imagine that this is going to be inherited to here and also here. Dynamically, or at the runtime, for rectangle, the length of this size array is going to be 4. And the length of this array in the case of triangle is going to be 3. Right? Let's now make some notes very quickly. It's going to be very important before I show you the code. But conceptually, you should really get it clear. Okay, so here, this one over here is going to be inherited to here. So now you can think about, in the case of a rectangle, size dot length should be 4. On the other hand, the same attribute should also be inherited to the triangle class. And in that case, size dot length should be equal to 3. But they are in both cases they are simply an array. It's just that the size will be different dynamically at the runtime. And in the case of row, we can simply I'll show you the code in a moment, but for the row, you can simply just try to maybe use a loop to go over every member in the size and try to increment it somehow to make it bigger. And also get perimeter over here. How do we do it? Well, you can do it in a uniform way, between the two subclasses. You can simply use a loop again and then accumulates the summation of all the values in the size into a number. That's what you can do. The only thing that cannot be defined at this level over here would be the get area. That is why I simply put this as empty. There's a reason to actually I talk about this last, because that's really important. So here you can see here, this is empty implementation. Okay. So here, this is empty implementation. Okay, because at this level of the parent class, we don't know how to calculate the area, because at the subclass level it can either be a rectangle or it can be a triangle. So we are trying to delay the decision about which mechanism to use to calculate the area. All right. Okay, let me just say one more thing over here. So that means it's going to be delayed. So empty implementation, you can think about conceptually it is delayed to both subclasses, delayed or deferred to subclasses. And let's now take a look at how exactly it will be defined. It will be implemented accordingly in both subclasses. Let's take a look at a rectangle, right? So here we're simply redeclaring the same get area method, so that will effectively overwrite the method. And whatever we put inside. So now one question for you. Given that this is empty, do we really need to say super.getArea over here? Well, you can do it, but it's simply not very useful, would it? Because this implementation here is simply just empty, doing nothing. In that case, calling that implementation using super here is not going to give you any result. So I would say we don't need to bother. Okay. So over here, this part over here is going to calculate the area of the rectangle by using, let's say, this illustration over here, right? You're just going to multiply the width by the length. That's what you would do, right? We'll see exactly how to do that. Similarly, in the case of get area for triangle, you can see, right? So we are also redeclaring the same method, get area over here. And now the way to do that is by implementing faithfully the formula over here, right? We're going to calculate, so given A, B, and C. Well, I just happen to draw this triangle as the right angle triangle, but in general, it could be simply just A, B, and C, like that, right? It can be A, it can be B, it can be C. And we are making the assumption that the values for A, B, and C are simply valid, meaning in the sense that any two sides, their sum should be larger than the third side. So it's a very basic healthiness condition for the triangle. And once we do A, B, and C, and we can calculate S, which will be half of the parameter, and also we can do S minus A, S minus B, S minus C, multiply them together, and then take the square root. And we're going to use the math class to help us do the calculation for the square root. Okay, so that's about the walkthrough of how you might do it using the inheritance construct that you learned in the earlier lecture. All right. So what's the disadvantage for this design over here, right? The disadvantage, I'll just be picky here. I would say it is this part over here. If you simply just put this method empty, it looks a little bit awkward, because every time when you declare a method in Java, you definitely should put at least something there to be executed, right? Conceptually, that also makes sense. Otherwise, why would you declare the method in the first place, right? What if we didn't actually declare this method over here, right? Let me just say hypothetically. Hypothetically, let's say we simply got rid of this method over here. So that means get area is no longer the expectation for polygon. It's no longer there. And we are only declaring the new method get area in the rectangle side. And also we are declaring this new method get area on the triangle side. Right? That's what we're doing. What will be the consequence of that? Okay? It's very worth mentioning to know about the consequence of an alternative design. Let's say alternative. Let's say no get area in polygon. Okay, so now here is the question. What will be the disadvantage for that? I'll give you one hint, and then you can actually think about it and pause the video. Okay, the hints will be, if we simply don't have this get area over here, are we still able to create some polymorphic collection of polygons? Okay, let me write down the hints, and then you can pause the video and think about it. So the hints will be polymorphic collection of polygons. Would that still be possible, given that we actually got rid of this method here at this level, since we don't find the empty body of implementation to be too appealing? All right. Okay, pause the video and think about it. All right. Hopefully you thought about it. Let me recap very quickly. It's very important to understand why we're doing this additional exercise for you. It's more about sharpening your judgment call about design. So we talk about this particular alternative where we simply don't have this line over here, meaning that the get area is no longer part of the expectation for polygon. Instead, it will be the expectation on rectangle and also triangle, only on the subclasses, not on the parent class anymore. Okay, and then the hints I spoke about was about polymorphic collection. You can see I kept emphasizing this term since last week, since we introduced to you this idea. Is very, very crucial. All right, let me tell you why this would not be a good idea. Why it wouldn't be a good idea to actually get rid of this. Okay, let's now use a concrete example to illustrate. Let me put it over here. Okay, so the justification would be over here. Okay, so the alternative is not good, not appropriate. The alternative design, which I just proposed before you pause the video, was not appropriate. Why? Because let's think about this. If I have something like a polygon array, and then PS over here, of course, let's say somehow we got several lines of code over here, assuming that PS is actually assigned to some new array of polygon with certain size. Let's say we have done that already. Okay, it's analogous to we declare students array in the student management system, right? We simply got student class over here. In that case, dynamically, each member in the array can be any of the descending classes of the student class, which can be either resident students or non-resident students. If you're not too sure about this, please refer to last week's video about polymorphic method parameters. Okay, so now let's say this. Given that we already initialized a PS, can we just simply write a loop as follows over here? Can I simply say for, let's say, integer I, maybe initialized to be 0, I strictly less than maybe a number of polygons. Let's say this is something that we actually declare according to our programming pattern. And then I++. So we are basically go over the polygons one by one. And let's say for every one of the polygons, we actually want to get its area. Okay? And we want to accumulate the sum of the area, let's say. So here we say double. Over here, let's say the total sum of the area, initially 0. Okay? And then here we're going to say total plus equal. Similar to earlier, if we go over, let's say, the polymorphic collection of students, we can register a common course for each one of them, right? That's what we said earlier last week. Now we want to do something similar. So I would say the polygons array declared to be polygon. That means every member statically should be a polygon. So now I say PSI dot get area. This is something that we would expect to do. Similar to how we did it in the student example for polymorphic collection. Is this still possible given that we got rid of this declaration for get area? All right. Hopefully that's something you thought about when you actually pause the video, right? Let me now get to it. You can see according to the declaration, we know that every member in the PS array is statically going to be a polygon. Okay, that's something important. Static type of each member or elements. Let me say elements, right? But we might use a member and elements interchangeably. Each element of PS is simply polygon. Now, as far as compilation is concerned, we spoke about earlier when we summarized the rules about type checking, you only have to judge to see what the static type is for the context object, right? You can see this is the one I just highlighted, the one I just boxed over here is a context object for the get area method call, right? So now you can see PSI over here, PS and index I over here. What's its static type? Well, according to our analysis over here, it should be polygon. Now, can we expect to call get area on polygon? Well, apparently we cannot because we got rid of it. So simply getting rid of this method declaration just because we don't like the empty body of implementation is not a good idea. If you simply got rid of it, then you wouldn't be able to do what we can normally do on a polymorphic collection, which is to call the get area over here, and then depending on the dynamic type, we may either call this version over here or this version here, but it's no longer possible because it's already gotten rid of from the expectation on the static type polygon. Hopefully you are getting the idea. Okay, let me write it down shortly just for your reference. Okay. Okay, so this part over here is not going to compile. Okay, so let me just write it down over here. Not compiling. Because get area cannot be expected on polygon. On polygon. All right, so that's basically the answer I was hoping that you will be able to derive during the pause of the video. But if you haven't really got this far, that's okay, but at least study what I just said about the reasoning. Okay, so let me recap, and then we can move on to the abstract method. So the very initial solution I proposed to you was we simply got this get area method, but the body of implementation is simply just empty. The advantage of that is when we try to do things like this, that get area over here, the static type polygon will still support get area over here. So as long as the dynamic type is either rectangle or triangle, we will be okay. We just make sure we call the corresponding version, right? That's design number one. Design number two, since we didn't quite like having the empty implementation over here, so we've asked ourselves, what if we got rid of this line over here, meaning that the get area is no longer the expectation for polygon. But we know that design number two was not good, the alternative, because in the case of manipulating the polymorphic array of polygons, in that case, get area is no longer part of the expectation for polygon, so it's not even going to compile. So design number two is definitely a no-no. Okay, design number one is good, but we really don't want to have the awkward syntax of just empty brackets of curly brackets. Okay, how can we improve it? So in this case, we need an abstract keyword. Okay, so let me just write down briefly about what we can do. Okay, so the ideal solution is we want to use the abstract keyword. Use the abstract keyword. Okay, so this is what, as far as I would say on this page. So we know that we need the abstract keyword to improve the original design rather than just empty body of implementation. But of course, that will be the best you could do based on what you learned on the previous week. All right, hopefully that's clear to you so far. Let me now present to you the ultimate solution using the abstract.